Yes, hello guys. We have another session here, and we're going to look at our next set of questions. This is elective math lesson one, and we are looking at four DOKs. And the strand for today is modeling with algebra. The substrand is number and algebraic patterns. Modeling with algebra, number, and algebraic patterns. So would like to first start off with, by the way, this is Mr. Smart. Say hello to Mr. Smart. I would like to start off with level one. So level one type of question. Mr. Smart is going to take us through level one type of questions. So in this level one, we are giving that. So let Mr. Smart sit on the side a bit for us for level one. Mr. Smart will come back. So given that um, A star B, so let's get down to business. Given that A star B, yes, given that A star B, given that A star B is given by A, this is given by A plus B, A plus B, given by A plus B plus 2, A plus B plus 2. Yes, where A and B are real numbers. Find the identity element. So we need identity element. You know what the identity element symbol is? Is E. So we're supposed to find the identity element. So in finding identity element, it means you're replacing element B with E as the identity element. This means that we'll still have to replace the B here. Now notice that with the identity element produces the same element. So identity element will produce element A. So A star E should give us A. So the B that we're looking for is the identity element. Obviously, A plus B, which is now our E, is plus 2, will be equal to A. Will be equal to A. So solving this gives us the identity element. In other words, A operated on the identity element gives you A. So this is the operation combination for star that allows us to find this relationship, this identity element relationship. Yes, but naturally, the operation was this. Without this, all we knew is that this relationship was valid. In other words, A star B gives this. So if we are interested in the identity element, which is the element that operates with A to give you A itself, we can then rewrite this, rearrange this by writing it as A plus E plus 2 should give you, like the formula requires, give us A back. So we just make A the subject. Oh, sorry, make E the subject. Making E the subject requires that we take this to the other side of the equal sign. which means that it becomes -2. So sending +2 becomes -2 on the other side of the equal sign. So it becomes A minus 2. But notice that E here is added on to A. But A needs to leave for E to stand alone. It means that we still have our E. We still have our E here. Yes. And then our A, which is positive, will now assume -A as it comes off. Yes. -A as we come back to add. So the identity element for E will be equal to A minus 2, A minus 2 minus A again. So notice that I can, by association, this in association with this, but I can also rearrange it and have a different association such that A minus A cancel out to give us what? 0. A minus A cancel out to give us 0. That means that the identity element is -2. So if we are correct by this assumption or by this deduction, it means that when we place 2 as identity element, or rather -2 as identity element, any number we use with -2 will produce the same number. Any number that is operated with -2 will produce the same number. So this should be the identity element in this operation star. So the next thing that we look out for, you can just place this on the side here. Next thing that we look out for is the DOK level 2. DOK level 2. Yeah, so put this here. So in DOK level 2, the question is that a binary operation on triangle is defined on a set. So let's create a binary operation on triangle. So we have an operation triangle, and a binary operation triangle, and a binary operation is defined on a set 1, 2, let's set 2, 3, 4, and 5. So the set of numbers that work on this operation are 2, 3, 4, and 5. So let's fit it into here. Yeah, so we have 2, 3, 4, and 5. These are the elements that operate within this binary operation of triangle. And then, so we have a binary operation triangle is defined on a set by PQ is equal, so this is P with Q. Yeah, P with Q. And P with Q is given by P plus Q minus PQ. So this would be P plus Q minus PQ. So this is the explanation for triangle. So triangle is given by this relationship and operated on these members. So the question is now, construct a table for the operation triangle on the set and determine whether or not the operation is commutative. So I'm supposed to construct a table. So what we have to do is work out a table for this. In other words, you can place the add math over here, push this a bit, and this is given by P plus Q plus PQ. So let's form the table. The table is just figure we'll just structure them here as our members of the table. So we have 2, we have 3, we have 4, and then we have 5. 5, 2, 3, 4, 5. So with 2, 3, 4, 5, our job is to now fill in the table for triangle. So this here will be triangle. And we're interested in 2, 3, 4, 5. So the first one obviously is 2, 2. So if we want to run 2, 2, it means that P is 2, P is 2, and Q is also 2. Oh, my bad. I need to write 2 instead. Let's wipe this. And I need to write 2. So triangle 2. And what it means is that I'm supposed to replace P with 2 and Q with 2 for the solution. P with 2. Oh, I keep repeating this. P with 2, that's my error. So P with 2. And Q also gives us 2. Yeah. So we're adding on. So adding on. And then we have minus P times Q. So minus 2 times 2. So obviously, we'll put this here. And the answer for this operation will live here. So 2 plus 2, that's 4. 2 times, so brackets will let me solve the 2 times 2 first. So this is 4. So 4 minus 4, and that gives you 0. So by filling up the table, we'll be able to figure out to what extent. So we'll fill out the table and check the diagonal to see whether the members on either side of the diagonal are the same. If the members on the other side of the diagonal are the same as is indicated here, then we will have a case of commutative property if the members on the other side are the same. Yeah. So for now, that's DOK level 2. We just completed level 2. This is level 2. So for now, we will sample level 2 away. Sample level 2. Commutative. And let me know your answer once you've been able to carry it out. Now, the next part, DOK level 3, we have an interesting question here. The DOK level 3 is given that A A star B. So this involves squares. So A star B, given that A star B, given that A star B is equal to A squared plus B squared minus AB is equal to A squared plus B squared minus AB. Yeah, so this is what the star is represented by. And then we have a trick on it is that 5 operation y. So 5 operation y is equal to 5 operation y is equal to 19. And our job is simple. Find the value of y. We're supposed to find the value of y. Interesting. So what it means is that we're going to place the value of 5 here as our a and y as our b and equate it to what? 19 and solve this. I'll be interested in knowing how you come up with this. So this is 5 squared plus y squared minus 5y all equal 19. And then we solve. So obviously this runs into a quadratic. Yes, and I'll be interested in knowing how you solve this quadratic problem in class. So this is a level 3 problem. So this here is a level 3. This is a level 3 problem. So we just place it here on the side for the time being. Now in level 4, for a level 4 problem, we will just keep this away for the meantime. Level 4 problem means that we have a problem on hand. So level 4 problem is the story is at a coastal fishing market. Let's draw our fish. So a coastal fishing market. So a coastal fishing market uses binary operations to calculate combined profits from 2 traders. The operation is defined as circle star. So this is the operation that picks the fish from trader A into trader B, and how is the breakdown? So the breakdown for this fish market for trader A and trader B is this: is 2AB minus, that's 2 attached to AB, 2AB minus, so there's a minus 3, which is attached to A, and then plus B, and closed up. So this here, these are the 2 terms involved. The first term for this binary operation is twice AB minus 3 times A plus B, where A, B represent individual profits in Ghana cedis. So explain how you will determine if this operation has an identity element. How will you determine if this operation has an identity element? That's the question on hand. And if a trader A his profit is 500 Ghana cedis when A is 5. Trader A has his profit is 500 Ghana cedis when A is 5. And trader B's profit is 300 Ghana cedis when B is 3. Calculate their combined profit using the operation. Want to know the combined profit using the operation. So we're going to let 5 stand for 500 Ghana cedis and 3 stand for the 300 Ghana cedis. So instead of writing 500, we just use the 3 and the 5 and run it on the operation, after which we attach the zeros to make the amount in cedis. So over here too, interesting question. If the has trader A has 500 Ghana cedis or 5, and trader B has a profit of 300 Ghana cedis or 3. Investigate whether the operation is commutative and explain the implications back in class. Thank you. Remember, BHM puzzles. Think like an AI.